here to review from Wednesday. I put these up here because these are ones that typically people don't know the conversion off the top of their heads. So they generally have to either look up the equivalency or do some other means to find it. And then we have to use our conversion methods. That dimensional analysis, remember, is the name of it. So let's take a look at the first one here. We had 155 pounds going into kilograms. So in order to make that conversion, I turned the 155 pounds into a fraction by just putting it over 1. And then I need an equivalency between pounds and kilograms. And if I look up, I get the equivalency. 1 kilogram is approximately 2.2 pounds. So up here in my conversion factor, I have pounds on top. I need to get it to cancel out, so I'm going to put pounds on bottom here. So 2.2 pounds equals 1 kilogram. Now remember, this is a unity fraction. Even though it doesn't look like it, the numerator and the denominator have the same value. This equivalency says they're the same. And so we can multiply it by that because it has a value of 1. We can multiply by it to change the appearance of our number without actually changing the value. So here the pounds cancel out. We have 155 times 1 kilogram is 155 kilograms. Over 1 times 2.2 is 2.2. And now looking at this, we see that we have to divide out by the 2.2. So we take our 155 by 2.2, we get 70.45 kilograms. So 155 pounds is equivalent to 70.45 kilograms. This next one, 12 teaspoons going into fluid ounces. So we start out with the 12 teaspoons. And again, we'll put it over 1. When we look in our equivalencies, though, we don't have an equivalency that goes directly from teaspoons to fluid ounces. We have an equivalency that says 1 tablespoon equals 3 teaspoons. And we have another equivalency that says 1 fluid ounce equals 2 tablespoons. So we have to go through 2 steps to get from teaspoons to fluid ounces. Either way, we're getting rid of teaspoons first, and since teaspoons are on top here, we put teaspoons on bottom here, so they'll cancel out. This is the equivalency that has teaspoons in it, so 3 teaspoons is equivalent to 1 tablespoon. So again, the teaspoons cancel out. And remember, that fraction is equivalent to 1 because 1 tablespoon and 3 teaspoons are the same thing. There's 2 different ways of representing the same value. Well, we don't want tablespoons. We want fluid ounces. So we have to keep converting here. So in our next step, we have to get rid of the tablespoons. Since tablespoons are on top, we're going to put tablespoons on bottom. This equivalency has tablespoons in it. It says 2 tablespoons equals 1 fluid ounce. So 2 tablespoons, 1 fluid ounce. So now the tablespoons cancel out in our fractions. We multiply on top. We have 12 times 1 fluid ounce. 12 fluid ounces. On bottom, 1 times 3 times 2 is just 6. So then we have to divide that out. 12 fluid ounces divided by 6 is 2 fluid ounces. So 12 teaspoons is equivalent to 2 fluid ounces. And this last one, finally. I'll make some room here. 2 fluid ounces going into milliliters. Well, again, we start with the fluid ounces. We just put 2 fluid ounces over 1. And we find an equivalency that says 1 fluid ounce equals 30 milliliters. Now, this is one that's kind of ironic. In your textbook, it depends on what page you look at. On one page of the textbook, it says 1 fluid ounce equals 30 milliliters. You flip the page, and literally the next page says 1 fluid ounce is 29.9 milliliters. It's actually somewhere in between there. somewhere around 29.945. We round it to 30 is close enough for what we need to do. So again, fluid ounces are on top, so we're going to put them on bottom to get rid of them. 1 fluid ounce equals 30 milliliters. So the fluid ounces cancel out. On top, we have 2 times 30 milliliters is 60 milliliters. On bottom, 1 times 1 is 1. So there's nothing to divide out there. It's divided by 1, so that's just 60 milliliters. So you can see this dimensional analysis is a pretty powerful tool. Even though these are units that conversions we have not made before, fluid ounces to milliliters especially, as long as we just stick with finding the equivalencies, putting things in the place in the dimensional analysis where they belong, everything works out. The units basically tell us what to do. Dimensional analysis actually goes even deeper. If you're working, let's say you are driving and you are going 70 miles per hour, and you have a gas mileage of 20 miles per gallon. We want to make the conversion. We want to find your fuel consumption in gallons per hour. Sounds like a complex thing. It's not one that we've memorized the formula for, but we can use the dimensional analysis. First thing, each of these rates is also an equivalency. 70 miles per hour is saying 70 miles is equivalent to 1 hour of travel. 20 miles per gallon is saying 20 miles is equivalent to 1 gallon of fuel consumption. Now we look in our final answer to see what units we have. We have gallons on top and hours on bottom. So we need to either find one of these units here, one of these equivalencies that have gallons on top. When we look at this one has miles on top. Actually, they both have miles on top. So we're not going to shoot for that one. So the next thing we try is let's find something that has hours in the bottom of the unit. Well, this one right here has hours in the bottom of the unit. So we're going to start with that 70 miles per hour. And we're going to write it as 70 miles over 1 hour. Remember when we talked about rates, that unit rate, we have to write it in that form so that we can calculate with it. Now we need to get rid of the miles. So I'll put miles over here. We have this equivalency. It says 20 miles is equivalent to 1 gallon of consumption. The miles cancel out. 70 times 1 gallon is 70 gallons. 1 hour times 20 is 20 hours. And we divide that out. 70 gallons divided by 20 hours. Remember, to turn it into a unit rate, we divide by the number of the second value. So just the 20. 70 gallons divided by 20 is 3.5 gallons. 20 hours divided by 20 is 1 hour. So that's 3.5 gallons over 1 hour, which is a unit rate of 3.5 gallons per hour. Again, a formula, we did not have a formula memorized there, but matching up the units told us what the calculation had to be. In our next unit, most of our calculations with dosage calculations can be done by simply doing the dimensional analysis, looking at where we start and then going from there to get to using the units to get to where we need to go. Now this can be even more complicated with our dimensional analysis. We can deal with compound units. For example, let's say I tell you I can throw a baseball at a rate of 90 feet per second. Raise your hand if you think I can throw that fast. Sounds pretty fast, doesn't it? Well, how fast is it really? Well, we're used to seeing speeds in miles per hour. So let's make that conversion. We'll start out with our 90 feet per second. But again, we write it as 90 feet over 1 second. Remember, as a unit rate, we need it in that form to calculate with it. Now we look at the units. On top, we started with feet and we're converting to miles. So we're going to change that feet into miles. The feet are on top now, so we're going to put feet on bottom. Miles will go on top. And our equivalency here, I'm not going to write it out, but we know that 1 mile is 5,280 feet. So the miles will cancel out. So now we have miles in the top of our units. That's what we want, miles in the top of the units. Going back here, we started out with seconds in the bottom of our units. We need to get to hours. So here, seconds are on bottom, so to get rid of it, we're going to put seconds on top. We don't have a direct line to hours, but we can go to minutes. So we'll put minutes on bottom. 1 minute is 60 seconds, and the seconds have canceled out. Right now we have minutes in the bottom of our unit. We want hours, so we need to go one more step. So we'll put minutes on top here so they cancel out, going into hours. 1 hour is 60 minutes. Now the minutes cancel out. And now the only units we have on top are miles, which is what we want, and on bottom is hours, which is also what we want. So we'll multiply this out and divide it if we need to. So on top, 90 times 1 mile times 60 times 60. What is that? 324,000 miles is the unit that's there. On bottom, 1 times 5,280 times 1 hour is 5,280 hours. And now we have to divide out. We divide by the 5,280. Get 1 hour on bottom. We divide by 5,280 on top. What is that, like 61.34? I'll double check it here. 324,000 divided by 5,280. It is 61.36 miles. So that is 61.36 miles per hour. To be honest, I don't know if I could still throw that fast. A few years ago, I probably still could, but I don't know if my shoulder could take it anymore. So we can work our conversions with these dual units using that dimensional analysis. So we might have problems like, oops, that's not what I wanted. With our metric units, we might have something like 340 grams per liter, and want to know what is that in milligrams per milliliter. Well, we write it as 340 grams over 1 liter. We want to get from, on the top of our units, we're going to get from grams to milligrams. Well, grams are on top, so we're going to put them on bottom. Grams are the larger unit, so I'm going to make it 1 gram. And then I look to see how many milligrams are in 1 gram. Well, milli means 1,000. There's 1,000 milligrams in 1 gram. So the grams have canceled out. Now we have milligrams on top. We need to get to milliliters on bottom. So we currently have liters on bottom, so put liters on top, going into milliliters. Liters are the bigger unit, so I make that 1. Now, milliliters, there's 1,000 milliliters in 1 liter. Again, milli means 1,000. So we multiply this out on top. Of course, the liters have canceled out. 340 times 1,000 milligrams is 340,000 milligrams. On bottom, 1 times 1,000 milliliters is 1,000 milliliters. And then again, we divide this out. The bottom number is 1,000, so we divide by 1,000 in both numbers. 340,000 milligrams divided by 1,000 is just 340 milligrams. 1,000 milliliters divided by 1,000 is just 1 milliliter. So that is 340 milligrams per milliliter. Another example we might have 37 milligrams per milliliter, and want to know what is this in milligrams per liter. So here we notice there's only one unit that's changing. Let's write this out. We got 37 milligrams over 1 milliliter. On top, we have milligrams, and we want to keep it milligrams, so we don't have to change that unit. On bottom, we have milliliters, and we want to change it to liters. So to get rid of the milliliters are on bottom, so we're going to put milliliters on top. We're changing the milliliters to liters, so we'll put liters on bottom. Again, since this is metric, we find the larger unit, which is liters. And 1 liter is 1,000 milliliters. If you have to use the chart and move the decimal point for the 1, go ahead and do that. The milliliters cancel out. 37 milligrams times 1,000 is 37,000 milligrams. 1 times 1 liter is 1 liter. Well, the bottom is already just a 1 unit, so we don't have to divide it out. It's just 37,000 milligrams per liter. Now, the textbook gets a little carried away with the dimensional analysis. They throw up some kind of ridiculous units like meter to the negative 1. Well, that's just the reciprocal of meter. Meter to the negative 1, as we saw with our exponents, that's just 1 over a meter. The biggest thing to remember is if you have a meter to the power of negative 1 times just a regular meter, well, anything times its reciprocal, that would be 1 over a meter times a meter. Or make this a meter over 1, well, it's a meter over a meter, which is just 1. So a unit to the power of negative 1 times its regular unit always multiplies to equal 1. So in the textbook, like I said, they'll give you some that are a little ridiculous, like milliliters over grams squared. First of all, what is a gram squared? I really don't know. It's not a practical unit. Times grams over grams to the negative 1. So to do a problem like this, what I'm going to do is I'm going to take the gram squared and I'm going to cross it off. I'm just going to write it as grams times grams. Then I can cross cancel. I have a gram here and a gram here diagonal, so those cancel out. I can cancel out the grams. Now on top I have milliliters. On bottom I have grams times grams to the negative 1. Well, remember what we said up here, anytime you have a unit times the same unit to the power of negative 1, they just cancel out to multiply to make 1. So grams times gram to the negative 1 is just 1. So that's just milliliters over 1, or just milliliters is the units we get there. Or something like milliliters per minute times milligrams per milliliter. Now this is actually a little bit more practical dimensional analysis. Here, simply the milliliters cancel out. They're diagonal. So on top, we just have the milligrams. On bottom, we just have the minutes. That reduces to milligrams per minute. There's one final unit conversion that I want to talk about that works a little different from the others, and that is temperature. So in temperature, we have our 2 scales. We have the Fahrenheit scale, and we have the Celsius scale. Well, the Fahrenheit scale is our customary or standard scale. Wrote that pretty sloppy. Let me try that again. And the Celsius scale is the metric. And our benchmarks that we use in temperature is the temperature at which water freezes and the temperature at which water boils. And of course, this time of year in the Fahrenheit scale, we're very conscious of the temperature at which water freezes. It's at 32 degrees Fahrenheit. Temperature which water boils is 212 degrees Fahrenheit. On the other side, in the metric system, water freezes at 0 degrees Fahrenheit or Celsius, and it boils at 100 degrees Celsius. So the first thing I want to point out is the range here. From water freezing to water boiling, in the Fahrenheit scale, that's 180 degrees. In the Celsius scale, that's only 100 degrees. So 1 degree Celsius is bigger than 1 degree Fahrenheit. Using those numbers to make a ratio, 1 degree Fahrenheit is equal to 5/9. 5/9 is just 100 over 180 reduced of 1 degree Celsius. Or the other way around, 1 degree Celsius is 9/5 of 1 degree Fahrenheit. Notice the 9/5 is just reciprocal. That's 180 over 100 reduced. But there's a bigger problem here, and that problem is that there is no common 0 point. In all of our other conversions, like for length, 0 centimeters was equal to 0 inches, equal to 0 feet, 0 meters. 0 was 0. There was no length there. For mass, mass and weight, 0 grams equals 0 pounds equals 0 kilograms. 0 was 0. And for capacity, 0 pints equals 0 milliliters equals 0 gallons equals 0 liters. 0 was 0. But in temperature, that's not true. 0 degrees Celsius is equivalent to 32 degrees Fahrenheit. So we are not able to use just a conversion factor or dimensional analysis to convert them. We have to have a conversion formula. So if I am going from degrees Fahrenheit to degrees Celsius, so to get my temperature in degrees Celsius, I start with my temperature in degrees Fahrenheit. And the first thing I have to do is I have to account for this difference in 0 point from 32 to 0. So I have to subtract 32 from my degrees Fahrenheit. And then I have to account for the difference in the size of the degree. 1 degree Celsius is 9/5 of a degree Fahrenheit. So actually, to get the degrees Celsius, we multiply by 5/9 to convert the other way. So for example here, let's look at human body temperature. Human body temperature is commonly accepted as 98.6 degrees Fahrenheit. If I want to know what is that in degrees Celsius, we'll put it into this formula. So our degrees Celsius is 5/9 times. For F, we put in the 98.6 minus 32. 98.6 minus 32 is 66.6. We've reduced that parentheses down to a single number, so I can take it out. Now I just have to do 5/9 times 66.6. Now on your calculator, if you don't have a fraction calculator, that's not a big deal. You just do 5 divided by 9 and then times 66.6. You get 37 degrees. So human body temperature of 98.6 degrees Fahrenheit is 37 degrees Celsius. What if I want to go the other direction? What if I want to go from degrees Celsius to degrees Fahrenheit? So I start out with my degrees Celsius. And again, I account for the difference in size first. I do it just the opposite as I did over here. So I'd multiply by 9/5. And then I account for that difference in 0 point. So then I add the 32. So let's say you are driving into school in the morning and the announcer says it's going to be 20 degrees Celsius today. Sounds chilly. 20 degrees Fahrenheit would definitely be a chilly day, but let's see what that actually is in degrees Fahrenheit. So we put 20 in for C here. So once again, if you don't have a fraction calculator, it's not a big deal. You just do 9 divided by 5 times 20, which is 36. And now we have 36 plus 32, 68. So 20 degrees Celsius is 68 degrees Fahrenheit. I would really love a day with that temperature right about now. We have about 14 minutes left, but I'm going to give you the homework now, and then I want to discuss the test coming up. The test is coming up on Monday. So homework here, page 114, 1 through 25, the odds. That is that dimensional analysis that I warned you about the textbook likes to get a little carried away with. So like I said, they'll do things like milligrams squared over liters to the -1 times meters to the -1 times liters or to the -1 over meters times milligrams. Well, there's a lot of mess here, and most of it cancels out. You know, the milligrams squared, I'm going to write as milligrams times milligrams. Now I have milligrams here and here, they cross cancel out. I have liters to the -1 here and here, they cross cancel out. So now on top, I just have milligrams. On bottom, meters to the -1 times meters is just 1. That whole thing reduces to milligrams. Also, then we have page, I believe I gave you this first page, yes, on Wednesday, but I'll give it to you again. 118, 1 through 19, the odd, dealing with some of the household units. And then with the temperature conversions, page 123, 1 through 21, the odds. Now, as I said, Monday is our Unit 2 test. Now, I realize Unit 1 test was pretty simple for most of us, and because it was just a review of previous arithmetic. And much of Unit 2 is also review, but I want to be careful because there are parts of it that take people by surprise. So let's go through and review what topics are going to be on this test. Now, these first couple are fairly simple. I'm solving equations. And order of operations. Those, again, are pretty simple, mostly like what you've seen before. But now some stuff that might be different than what you've seen before. We have those mixture problems. Remember, if we have 20 milliliters of 30% solution, how much 35% solution do we have to mix with it to make 34% solution? You know, those types of problems. So make sure you review those. Also, we're going to have rearranging formulas. So I might give you a formula like C1 times V1 equals C2 times V2 and ask you to solve it for V1. Well, that means I have to get V1 by itself. Right now, C1 is keeping it from being by itself. The C1's multiplying, so I have to divide by C1. That divides out there. V1 equals C2 V2 times C1. Another one that you've seen before will be evaluating an expression. In other words, this is just using formulas. If I give you a formula and I give you the value of every variable in the formula except for one, find the value of the formula. So it's partly order of operations, partly solving equations. We have reducing ratios you've seen before. And of course, solving proportions. And then some word problems. But our word problems are going to deal with measurement conversions. And ratios and proportions. Some of you may have used these before, but we're going to deal with scientific notation. Not just converting, but also calculating with. And then the one that most people you lose the most points on this test is all measurement conversions. Just like those several examples we saw at the beginning of the class today, they're conversions that we're just not used to doing, going from standard units to metric units, or from apothecary units or household units into apothecary units. Something to make sure you're very careful and make sure you brush up on those. And then, of course, there are going to be a few problems on the dimensional analysis. So now, as always, you will be allowed to use your book and your notes, and you can use your calculator on this test all the way through. So unlike test one, on this test, I do not require you to show your work, but if you do show your work, there's a chance for partial credit on a lot of these problems. Many of these problems have one step where it's pretty common to make a very small mistake, and so if you make that mistake, if you don't show your work, the problem's just wrong. I can't tell that that's the mistake you made. But if you do show your work and you make that common mistake, a lot of times I'd give you part of the credit for the problem because you had most of it right. You just made one common or one simple mistake. You do have unlimited time. We're only going to take one class period to do this. But you can arrange for as much time outside of class as you want to. You just have to have somebody in the school supervising you. And they don't have to sit there and watch you take it, but it just has to be in a controlled environment. You cannot take these with you and complete them and bring them back later. The only qualification is it must be completed by class time on March 10th. So that'll give you, if you work on it on Monday, if you have questions on it after class, there'll be time on the 8th on Wednesday to ask those questions and then still give you a little bit more time to finish up so they can be submitted by the 10th. So with that, does anybody have any questions on the unit test coming up on Monday or on the material we covered today? Okay, well, I guess we're out of here a couple minutes early today, so no problem. Like I said, make sure you do prepare for the test. Look over some of these topics, especially the mixture problems and the dimensional analysis, the measurement conversions. Students do tend to really struggle with this one. It's still a review of basic math yet, but this one does step it up a little bit in the test. And also, this is all stuff that we're going to need next unit. Next unit is where people's scores really start to drop because it's all going to be new stuff that you haven't seen before. With that, you guys have a great weekend, and hopefully we'll see you all on Monday.